Hello, guys. Let us now discuss the most important cycle in your syllabus, that is Rankine cycle. So, this cycle is actually used in the steam power plants, and uh, what is actually so you can see from here the Rankine cycle, also called the Rankine vapor cycle, is a thermal cycle that converts heat into mechanical energy. Okay, so the Rankine cycle is named after the William Johnson Maclaurin Rankine. So what is actually, so what Rankine cycle actually does, that is like same thing that the cycle is used in gas turbine. There is used as Joule cycle or Brayton cycle. So in steam in turbine we are using the steam cycle is used, that is called the Rankine cycle. So what it consists of, what are the parts in Rankine cycle, how it works, I will discuss here briefly here. So it is it can, if we go on it is on its systematic view, what is the Rankine cycle, you can see here in Rankine cycle there is a steam turbine, there is a condenser, there is a pump, there is a boiler, and boiler there are three stages have to be passed by by a water. Then it is formed finally into steam, that is equalizer, evaporator, and superator. And so boiler consists of three parts, that is equalizer, evaporator, and superator. So and boiler is also connected with the furnace, that is actually called a combustion chamber, where fuel air ratio is mixed and then burns, and it forms flue gases, and then flue gases are entered into the boiler, which gives it this required heat to form the steam. And also the boiler has one of a slot that is called exhaust gas to go outside. So let us see what happens actually in the this steam power plant. As you have already known what is steam turbine, जो आपने previous semester में पढ़ा होगा, what is steam turbine. It is velocity triangle diagrams type, what are its construction, and so everything you have done in previous semesters about the steam turbine. But in this stage we have to only discuss what is the function of steam turbine and what are its application in steam power plant. तो वो अब हम देखेंगे यहाँ पे कि स्टीम टरबाइन की यहाँ पे क्या रोल है, और हमें जो स्टीम टरबाइन की एक्चुअली कंस्ट्रक्शन है, बाकी जो मैथमेटिकल इक्वेशन जिसमें यूज होती है फॉर फॉर कैलकुलेट this efficiency, that will not be discussed here. And steam turbine is also here coupled with the electric generator, that is the main motive of the steam turbine, and that electric generator produces the current. So what happens actually there, so the at point one is mentioned here as steam is entered, pure steam form of steam is entered. It is mentioned as point one, it entered into this turbine, it enters into the steam turbine, and steam after the heat absorbed by the steam turbine from the steam, it is converted into mechanical energy here, and steam turbine does work here, WT. So that is considered as work done by the steam turbine. And after that it is then steam turbine is connected with the electric generator, and after steam turbine the point 2 is mentioned. Then after point 2 it is a condenser. The steam comes out from the condenser, the purest form of steam comes out from the condenser, then it is entered into the condenser. And what does condenser does, it converts this steam into liquid, that is water. So after that the condensation occurs, there is a point 3 is mentioned after the condenser. Then after condensation this liquid enters into the pump. Then what is the function of a pump lifts the liquid back to the boiler. From this side it lifts back to the boiler, and after the pump it is mentioned the point 4 here, and point 3 is mentioned between pump and condenser. So what there are two types of works done in this steam power plant. One is work done by the turbine, steam turbine. Second is work done on the pump, work done by the pumps. Since the pump uses electrical energy to does work, so that means it is actually called work done on the system. So it is not work done by system, it is a negative work, because the pump uses some electric energy to do the work. So that means, so now I will tell you what is the then after in what this boiler, what happens in boiler. When the liquid enters into the boiler, it first goes into the economizer, and what economizer does, it converts this this liquid into सैचुरेटेड लिक्विड. सो इकोनाइजर में क्या होता है कि इसमें स्टीम एक्चुअली प्रोड्यूस नहीं होती है, बट इट कन्वर्ट्स इनटू सैचुरेटेड liquid. Then it's mentioned after that point 5. Then after 5.5, then this saturated liquid enters into the evaporator. Then what is the function of evaporator? It evaporates this liquid into the steam, but that steam is not actually the purest form of steam. It is also mixed with some this water, so that is a mixture of steam and water. So but at point 6, uh, it uh, it is also a mixed form of steam and water. So it is not from point 5 to 6, it is evaporated actually, but steam is not pure steam up to point 5 6. So after point 6 is when it is further heated, superheated. It is called a superheater. It is further heated, then it is further heated up to that, up to the steam will be in the purest form from in superheater. Then at point 1, we there will be a pure dry steam which is entered and which is finally entered into the steam turbine. So after superheater we get this purest form of steam. So you can see from my notes that what is the function of economizer, evaporator, and superheater. So these are three parts of the boiler. So heat given to the boiler is represented by Q1, and it is used in evaporator, not in economizer. And in superheater, additional heat is given to the this steam. So these are PV and TS diagrams here. You can see that 1 to 2s. S represents as this S represents saturated point. 1 to 2s is here. You can see from the diagram 1 to 2s. It is the isentropic expansion process. 1 to 2. There's work of steam. Then 2 to 3 is the condensation process. Heat is rejected. Then it is 3 to 4. Then from 3 to 4 is the isentropic compression process. That is work done by the pump. It is 3 to 4. Then 4 to 1 is heat addition process. That is 4 to 1. It is the process of the boiler. It is work done from the in the boiler from 4 to 1. But it has three stages. That is 4 to 5. It is economizer. Then 5 to 6 is evaporator. Then 6 to 1 it is superheating steam. So this is TS diagram here, and this is HS diagram here. So these are Rankine cycle on PVTS and HS coordinates. So for calculating the equations of this, for calculating the work done and the thermal efficiency of the Rankine cycle, you have to suppose that 1 kg of fluid, you have to suppose 1 kg of fluid of water entered into the cycle, and you have to apply steady flow energy equations for the boiler as well as for all the sections. So you have to apply steady flow equation for all the processes. You have to consider steady flow energy equations, that is energy equations used for flow process. And it is the steady flow energy equations जो मेरे नोट में भी अवेलेबल है, वो आपको पहले पढ़ना है, what is steady flow energy equation. And you have to consider here also that the change in kinetic energy and potential energy in the steam in the water in the cycle remains constant, and they are neglected here. So that is why we are using only this enthalpy, heat transfer, and work done in all the processes. So next, how we are calculating this thermal efficiency of the Rankine cycle, it is discussed in next lecture. So you can already understand also from my notes that we are using steady flow and education for all the processes, for all the on all the processes, that is for turbine, for pump, for this condenser, and for this boiler. So on all portions you are using steady flow and equations, that is, and finally you are calculating the thermal efficiency. Thank you very much.